We will study right now the crankshafts. Crankshafts are made of a cast iron forged cast steel or nodular iron and then machined. At the center line of the crankshaft are the main bearing journals. These journals are machined to a very close tolerance because the weight and movement of the crankshaft are supported at these points. The number of main bearings varies with engine design. V-type engines have fewer main bearings than an inline engine with the same number of cylinders. A V-type engine uses a shorter crankshaft. Offset from the crankshaft center line are connecting rod journals. The degree of offset and number of journals depends on engine design. An inline six-cylinder engine has 6 connecting rod journals. A V6 engine may have only 3. Each journal has 2 rods attached to it, one from each side of the V, and the connecting rod journals is also called a crank pin. The position of the rod journals places the weight and the pressure from the piston away from the center of the crankshaft. This creates an imbalanced condition. To overcome this imbalance, counterweights are added to the crankshaft. These are positioned opposite the connecting rod journals. The main and rod bearing journals must have a very smooth surface. A clearance between the journals and bearing is needed to allow a film of oil to form. The crankshaft rotates on this film. If the crankshaft journals becomes out of round, tapered, or scored, the oil film will not form properly and the journals will contact the bearing surface. This causes early bearing or crankshaft failure. And we'll talk right now about the crankshaft torsional dampers. A combustion causes an extreme amount of pressure in a cylinder. This pressure is applied to the pistons and moves through the connecting rod to the crankshaft. This downward force causes the crankshaft to rotate. In an engine with more than one cylinder, this pressure is exerted at different places on the crankshaft and at different times. As a result, the crankshaft tends to twist and deflect, causing torsional harmonic vibrations, and these vibrations constantly change, but there are specific engine speeds where these harmonics are amplified. This increase in torsional vibration can cause damage to the crankshaft, the engine, and or any accessories that are driven by the crankshaft. These harmful vibrations are often limited by a torsional damper located at the front of the crankshaft. There are 2 common types of torsional dampers: harmonic balancers and fluid dampers. Both use friction to reduce crankshaft vibration. We have the flywheel, and the flywheel also helps the engine run smoother by applying a constant moving force to carry the crankshaft from one firing stroke to the next. Once the flywheel starts to rotate, its weight tends to keep it rotating, and the flywheel's inertia keeps the crankshaft rotating smoothly in spite of these pulses of power from the pistons. Because of its large diameter, the flywheel also makes a convenient point to connect the starter to the engine, and the large diameter supplies good gear reduction for the starter, so making it easy for it to run the engine against its compression. So the surface of the flywheel may be used as a part of the clutch on a vehicle with an automatic transmission. A lighter flux plate is used, and the torque converter provide the weight required to attain flywheel functions.